All right. Well, while you're working on the lab, I just want to also make sure you're not forgetting about the BigO examples that we've done and all the discussions. So for your mini quiz on Friday, there's going to be a bunch of BigO code, snippets of code that kind of looks like this, and then you would be expected to analyze it and tell me what the BigO is. Um, I want to do a couple examples here, and feel free to pause them before I reveal the answer, so you can see if your guess is correct. So I'm looking at the first example here, and it looks like so there's the first example, there's a single loop here, and k is gotten from the user. Now it's going n times, but n would be whatever the user says if it's less than 100,000, otherwise it'll be 100,000. So that means the worst case scenario is that loop will run 100,000 times. So that is a constant. So that means the big O here would just be O of 1. This is a constant loop. The second example right here, the first loop, so this is a double loop. So it's a nested loop. The first one is running n number of times, but the second one, it's doubling as it's going to n. So that means the efficiency of the first loop is n, and the efficiency of the second loop, the nested loop, is log n, because as this thing is getting bigger and bigger, like if this were to go from 10 to 20, it'll only run an additional one time to double it. So this is log n. So the big O of this guy is n log n. If this was just plus plus, then this would be n squared. All right, this one right here is also two loops, but they're not nested. So this loop will run n number of times, and this loop will run n number of times. So the big O of this is just n plus n, or 2n, but we don't care about coefficients. We're looking at the big picture. So this is just growing linearly. If n was, for example, 100, then this will be 100, and this will be 100. So that'll run 200 times. But if n was 200, then this would be 200, 200, so 400. So it went from 200 to 400. It's just doubling as n is doubling. So this is just growing linearly. This is just n. And finally, I have three loops here. This guy's running n times. This guy's running n times. This guy's running, I think this one's straightforward. This is just a nested loop. All of the loops are running n times. So that means the big O of this guy is n cubed. Okay, so I would say the only real trickery here is to watch out is how they're growing, like this guy. Make sure that's actually not a constant. Remember, you're analyzing the worst case scenario. And hopefully that should be good for your Friday mini quiz. Let me know if you have questions.